Welcome to another tutorial video from Tulla Maths. Make sure and subscribe for more. So in this video, let's investigate the unit circle a little bit further. We have our separate video on an introduction to the unit circle and labeling the points on the unit circle. So maybe check that out before we go a little bit further here. So what we want to have a look at basically today in this video is looking at the angles created within the circle and using our trigonometric ratios to spot angles of the same size. So I'm just going to show you here what I mean by that. So here I'm just creating an angle. You can see here it's 40 degrees. So what I'm doing here is when I'm creating my angle, we always go in an anti-clockwise motion, starting from the x-axis and working from backwards. If I was to bring that angle all the way back here, you can see that this angle is still now giving me 160 degrees. But I've created this new angle, which is known as the reference angle of 20 degrees. And I want you to see something here. If I was to continue down here a wee bit, let's go to about 190 degrees. So I just want you to test something there in your calculator. If you type in tan 190 degrees and also type in tan of 10, you should get the same answers. You should get 0.17. So they're telling us that they are the equivalent or the same sizes. And we want to investigate that a little bit more. How do we know that? How did we come up with the fact that they are equal in size? So here's my unit circle, and I'm just going to draw my radius line from the center out to the edge of the circle, and I'm giving that a length of 1 because it's my unit circle. I'm just going to drop a line down from my circle to the x-axis. This is my x-axis and my y-axis, and I'm creating that at a perpendicular angle, so I'm creating a 90 degree here. Now I've come out a positive amount of units on my x line, so I'm on the positive length here. So I'm just going to put a little plus here. So I've come out maybe 5 units or 6 units, whatever it may be. And I've gone up on my y-axis maybe 3 or 4, whatever amount of units, but it's going to be a positive number. So I've come out on my positive x-axis and gone up on my positive y-axis. And I'm going to create the angle there that I'm forming with that triangle. So I'm going to call it theta, the symbol for angle. Now let's investigate what happens when I find the sine, cos and tan of that angle theta. So I would have sine of my theta is equal to opposite over hypotenuse, and you can see that my opposite is going to be a positive number and my hypotenuse is positive 1, so that must also be a positive number. So basically, when I divide that fraction, opposite by hypotenuse or positive by positive, I'm getting a positive answer. What happens if we do the cos of theta? Well, my cos is going to be adjacent over hypotenuse. Once again, I'm focusing in on my triangle here. My adjacent is positive, my hypotenuse is 1, both positive. So I'm going to put them as both positive. So adjacent is positive, hypotenuse is positive. So therefore, my answer for cos of the angle must be positive. The answer for sine must be positive. And let's test for tan. My tan angle, O over A. Well, you can see from my triangle once again, my opposite, the theta, is a positive number. And my adjacent is also a positive number because I've come out a distance on the x-axis. So there, once again, my answer must be positive. So it doesn't matter if you're finding the sine, cos or tan of an angle smaller than 90 degrees, it's going to give me a positive answer. Test that on your calculator. So that's the sine, cos and tan dealt with for the first quadrant. So I'm just going to put a Q1 here beside that to represent quadrant 1. My triangle or my unit circle is broken into 4 quadrants. The top right is my quadrant 1, then I rotate anti-clockwise, quadrant 2, quadrant 3, quadrant 4. So now we are basically going to work our way around this unit circle doing sine, cos and tan for triangles. So let's go into quadrant 2 now. I'm going to create that same triangle. I'm going to use my unit circle, so my radius of 1. I'm going to drop my line down. I'm going to create my 90 degree angle with the x-axis. And I'm going to fill in some information. I've gone back on my x-axis, So I'm going into the negative numbers now. So whatever that value is, it's going to be a negative number on my x-axis. But I'm going up on my y-axis, which is into the positives. So that must give me a positive for the value of y. Okay, so I'm just putting a little plus and a minus, and then I'm creating my angle theta, my reference angle once again. And over here now, I'm basically going to do out my sine, cos, and tan. So my sine theta is giving me opposite over hypotenuse. Check your little diagram down here. My opposite is a positive number. It's going up on the x-axis. My hypotenuse is 1, which is a positive. So therefore, divide a positive by positive must give me a positive answer. I'm now going to test my cos theta, which is adjacent over hypotenuse. And adjacent, now look at, my adjacent is a negative value. So I'm now going to be putting in a minus for my adjacent. My hypotenuse is 1, my radius, so I'm putting a plus here. And we know that a negative, apologies about that, we know that a negative divided by a positive must give me a negative answer. So I'm going to put a negative here. Now I'm going to do out tan theta, which is opposite over adjacent. And from my unit circle, you can see your opposite is a positive and your adjacent is a negative. So my adjacent is still on the x-axis. My opposite, I'm going up on the y-axis, so that's a positive. So my answer is a positive divided by a negative, which must give me a negative. So that's quadrant 2 dealt with. So you can see here that the only one that's going to give you a positive answer is going to be sine in quadrant 2. Let's just make up an example. If you go to your calculator and type in sine of, say, 100, an angle bigger than 90 and less than 180, you'll get a positive answer. Type in cos 100, you'll get a negative answer. Type in tan 100, you'll get a negative answer. So the only one in quadrant 2 that will give you a positive answer on your calculator is going to be the sine theta. Let's go down to quadrant 3. I'm going to create that triangle once again, coming from the center of my unit circle, created by the radius length of 1 for my unit circle, and I'm going to create the triangle. Creates a 90 degree at the x-axis. I have come back on my x-axis a negative length, so that's fine. And on my y-axis, I'm coming down into the negatives now. Look at this length here. It's going into the negatives on the y-axis. So that's going to give me a negative length on the y-axis. So they're both negative. The hypotenuse is positive because it's the unit circle. So let's again investigate what happens for my sine, cos, and tan. So you can hopefully see here now that the sine opposite over hypotenuse, my opposite the angle, let's create our angle there, theta once again. Opposite the theta, I'm just going to mark it in here so you can see it, is going to be this length here in green. So that's a negative. And you can also see that the hypotenuse is positive 1. So that is giving me a negative divided by a positive. And a negative divided by a positive gives me a negative. I come down to my cos, which is adjacent over hypotenuse. Adjacent is on the x-axis, which is a negative again. And my hypotenuse is the positive 1 of radius. A negative divided by a positive is a negative. Look at the tan. Tan is opposite over adjacent. Opposite, which is the length on the y-axis, is a negative. And my adjacent is going to be on my x-axis. It's this line here that I've marked in green on the picture. And that is also a negative length. So that's giving me a negative divided by a negative, which is a positive. Now again, test it on your calculator. Make up one. Let's say it's an angle between 180 and 270. So say the angle 200. Type in sine of 200. Type in cos of 200. Type in tan of 200. The only one that will give you a positive answer is tan. So that is quadrant 3. And we are on to our final quadrant, quadrant 4, over here to the bottom right. So I'm going to draw my radius. I'm creating that triangle once again out of it, hitting the x-axis at 90 degrees and forming your angle of theta. You can see that I've marked the positive, see here, the positive, the plus sign. So I've come out a positive on the x-axis, but you can see now that I'm going negative on the y-axis. So I'm going to put a little negative symbol in here where I'm decreasing on the y-axis. Let me just draw back in my line there. I've lost it. Okay, so let's again find sine, cos and tan in quadrant 4. So our sine theta is going to be opposite over hypotenuse. Opposite is on the y-axis this time, so it's this length here that I've highlighted in green. That's a negative, and my hypotenuse is my radius, which is positive. So that is giving me a negative divided by a positive, which is a negative solution. My cos is adjacent, which is on the x-axis along here, which is positive, and I'm dividing it now by hypotenuse, which is 1, so that's giving me a positive divided by a positive, which is giving me a positive solution. When you divide a positive by positive, so 2 divided by 2 must be a positive 1. My tan is going to be opposite, which is across from theta, which is a negative, divided by adjacent, which is a positive, which is giving me negative divided by plus is a negative. So that's our fourth quadrant. Quadrant 4. Now, you have probably seen in textbooks the word C.A.S.T. This is the way to remember this. So I'm just going to write it down here, C.A.S.T. This is a quick way of remembering which ones are positive and which ones are negative. If I look at C, that's telling me that in quadrant 4, it's positive. So that's what the C stands for, cos. I'm going in an anti-clockwise motion now from quadrant 4. So the C in quadrant 4 is positive. The A stands for all in quadrant 1. So again, I'm going in that anti-clockwise motion. So C stands for cos, positive. So I'm going to put a little plus here. A stands for all being positive in quadrant 1. S stands for sine being positive in quadrant 2. Look at it over here, it's a positive. So in quadrant 2, it's giving me a plus. And in the final quadrant, quadrant 3, it's giving me tan as positive. And I'm going to put a little plus here. So that little rhyme, or that little rule, C.A.S.T, will help you to remember where cos, sine and tan are positive and negative in your unit circle. So now I'm going to take a few minutes to do some examples of putting that to use. So if you have time, maybe take a look at some of these examples now that we're going to go through. I've taken them from some examples from the book in Text and Tests. So there are some good examples, just to kind of give you an idea of why we are explaining the unit circle with the trigonometric ratios. So let's look at a few. So it wants us to use our formula tables to express each of these following as a fraction or a third. So what I would do, so they don't want us to use our calculator here. So what I'm going to do is just sketch what we basically just did, our unit circle. And I want you to see that they're talking about the angle of 120 degrees. So there's my 90, there's 180 and 270 on the y. So 120 is roughly around here. So I'm going back 120 degrees. That's what I'm doing. I've created a reference angle, as we mentioned a few minutes ago. That reference angle is going to give me the size of 60 degrees because I'm taking away the 180 minus the 120. So I'm just going to write in my reference angle there is 60 degrees. Now, if I use my rule from the C.A.S.T that we mentioned a few minutes ago, that would give me in the bottom quadrant 4, C is positive. Quadrant 1, all are positive. Quadrant 2, sine is positive. And in quadrant 3, it's the C.A.S.T, the T is positive. So what that is telling me that in quadrant 2, sine is going to give me a positive solution. So I now go to my log tables and I'm basically going to find the value of sine 60 degrees. And in my log tables, on page 13, sine of 60 degrees is giving me an answer of root 3 over 2. You can check that answer by typing in sine 120 on your calculator, and it should be the same as sine 60. So they're both giving you the same angle, the same answer. Let's look at this, the second one there, part V as I've written it. So it's going to ask us to find cos of 330. So once again, I'm going to draw out my XY graph. 0 degrees, 90 degrees, y-axis 270 degrees, and 180 degrees. I'm going now to the angle of 330 degrees, which is roughly around here. So I start at 0 and I go back to 330 degrees. Let me just write it in here. What's my reference angle there? Well, I'm starting at 360 minus the 330. That must give me a reference angle of 30 degrees. I then write in my little aid, my C.A.S.T, C-A plus. Sine is positive, tan is positive. Now I'm focusing in on that quadrant 4. It's telling me that only cos is positive in quadrant 4. So that's giving me cos of 30 degrees. I go to my log tables and I find on page 13 cos of 30, which is root 3 over 2. Giving us the same answer as the previous part of the question. So that's our answer. Again, to verify it, use your calculator and type in cos of 330 and cos of 30, and you should get the same answers. So let's take a look at these three questions. So which angle between 0 and 360 degrees has the same sine as each of these angles? So let's look at the one there at 56 degrees. So best way of doing these again is to draw out your unit circle and mark in the angle of 56 degrees. That'll help us. So that's my reference angle there of 56 degrees. And I'm on my x-axis, my y-axis at 270 degrees, 0 degrees, 90 degrees, and 180 degrees. We are now looking for the sine angle that's equivalent to it. So I'm going to draw out my C.A.S.T as my aid. So it begins with C positive, A positive for all, S positive for sine, T positive for tan positive. They're looking for sine, so I should be only focusing basically in quadrant 2. I'm looking for the sine to be positive. So what I'm going to do there is basically in the second quadrant, I'm going to mark my reference angle again in blue. It's going to be here at 56 degrees. Now I need to find what is that angle if I was to start basically at 0. So imagine I was here on my x-axis and I was to go all the way back to this line now. What's the value of that angle? That's what I have to find. And in order to find the value of that green angle that I've created, well, you know that the full x-axis is 180 degrees. So if I subtract the 56 degrees from the 180, that should give me the same angle, and that's giving me 124 degrees. So check it on your calculator. If you type in sine of 56 and sine of 124 on your calculator, they should give you the same answers. Okay, let's check out the second one here, 195 degrees. Sketch it out, mark where 195 degrees is. That's 0 on my x, 90 on my y, 270 and 180. Mark your reference angle there of 195 degrees, which is basically going anti-clockwise and is probably bringing me to about here. So that angle is 195 degrees. We now mark in your C.A.S.T. C.A.S.T, C positive for cos, all positive, sine positive, tan positive. We are looking now again for where sine is positive. So what I would do is I would mark in the reference angle here that I could also create. So look at this green angle now that I've created. What's the size of that angle? The angle there is going to give me 180 from 195, which is giving me 15 degrees. That green angle there is 15 degrees. And in that quadrant 3, sine is giving me a negative answer. So what I'm doing there basically is, if you go to your calculator just to test this, and you type in sine of 195, you should get a negative answer. So what I'm doing now is I'm looking for the sine of 15 degrees. But what I'm going to do is, because it's in a negative quadrant, I need to make it a negative. So that's giving me sine of 15 degrees, but I'm not technically in the 15 degrees in quadrant 1, which would be up here, which would be 15 degrees, which would be positive. So I need to make this a negative. So it's negative sine of 15 degrees. And again, check that on your calculator. If you type in minus sine of 15 degrees, it's going to get you a negative answer. So because you're in quarter 3, you have to make it negative for sine, because here it's only tan that is positive. Okay, so our last question. Take a look at this one. Find, correct to the nearest degree, the two values for which these angles in the range 0 to 360 degrees. So they've given me sine B is equal to minus 0.6947. Let's first of all find the size of the angle. So we're going to use our calculator here, and we're going to use our inverse button. So when we bring that sine over, it's becoming sine inverse with a little -1 of minus 0.6947. So if we go to our calculator and we type that in, we get 44 degrees for the size of the angle B. Sorry, my fault, minus 44 degrees. Okay, so B is equal to minus 44 degrees. Let's look at where that is on our unit circle. Let's draw a sketch here of our unit circle. Again, starting at 0, going up to 90 degrees, 180 degrees, 270 degrees on my y-axis. Minus 44 degrees is now going in the positive direction. So you know the way we always go anti-clockwise when we're marking our angles? This one now is going this direction. It's going down in my graph, so it's going like this. So it's going, it's actually going clockwise. So that's my 44 degrees, negative 44 degrees. Now I want to find the equivalent angles to that. And once again, we're going to use our C.A.S.T. So cos is positive, all is positive, sine is positive, tan is positive. Now this question is focusing in on sine, and we're looking at sine of a negative answer. So minus 0.6947. So where is sine negative? Sine is negative in quadrant 3. So sine is negative, so I'm just going to write them in here. So sine negative Q3 and in Q4. So they're the 4 quadrants that sine is negative. Down here, I'm just going to put a little star beside them, because only cos is positive there, and where tan is positive. So in quarter 3 and quarter 4. So let's find those equivalent angles now. So what I'm going to do is I'm going to use my reference angle of 44 degrees, and I'm going to do it here now in a green highlighter. So I'm going to come down here and I'm going to create that angle of 44 degrees. Now, if I'm starting from my original 0 degrees, if I come back to that angle is going to not be 44 degrees, but it's going to be 180 degrees plus my 44 degrees, which is 224 degrees. So that's my first value. I'm now going to find my second one, and we said that it's also negative in quadrant 4. So I keep continuing my green angle here, so I'm going to keep going around in circle until I get to this point here. And you can continue adding up to get to that point. The easier way could start with the full rotation of the circle is 360, go back your 44 degrees, and that's going to give me 316 degrees. So that full angle, I'm going to highlight it here in yellow on my picture, from here all the way back to here is 316 degrees. So there are my two values between 0 and 360 degrees. Hope this video helps. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.